Right? So then what is our steps? These are the things that if you don't know these and don't put them on every loop invariant test, you will get a 0. I mean, this is our bread and butter. All right? What do you need to know? You need to know, you need to write this on the top of your paragraph, and then you have to say, well, I know, right? You want to say here, what do I know because the precondition is true, right? And then at some point you have to write the code, and then you're going to write, what do I know because the code was executed, right? And then you wave your hands around, and then you want to say, then the loop invariant is true, right? So remember I talked about what level of formality we want, and I kind of implied this I'm going to be 100% anal about. 100%. You need to say, what do I know from the precondition? What do I know from that little piece of code at the beginning? And then you have to do your best. And then you have to say, hence, this is true. Right? Now, where can you be informal and wave your hands around? Here, we're not judging you on how formal you are. We're judging, can you make some sort of reasonable argument? Right? All right, so this is just, we're doing it here, right? Oh, this is exactly what I said, right? What do I know from the loop invariant? What do I know from the code, right? Is this true? Right? I don't even know what I would write in here other than, come on, dude, it's obvious. Right? So sometimes more or less, that's all you're saying. Everybody good with that? Yeah? No, I'll tell you what I'm giving you. I'm giving you the precondition. I'm giving you the postcondition. Right? And what are you giving me? Well, I'm recommending that the first thing you give me is the loop invariant, and then you give me this. Then you give me this code, and then you tell me how to maintain this code. Right? You do the steps that we're doing now. Right? All I'm going to give you is the precondition and the postcondition. Right? And I'll tell you what I'll also give you is I'll give you a bunch of hints, and I never quite know how many hints to give, and the reason is because remember I said, at least I've thought this is my third course, so I don't guarantee I say the things I said. I said it in some course, right, that I don't always know how hard a problem is for you, right? So I start with, oh, here's a problem, and I write it up, and then I start thinking, oh, are they going to get this? And if I start to panic, I add hints. And as I start to think it's too easy, I remove hints. And I'll tell you right now, last time I taught 3101 on the dynamic programming question, I started to panic that they wouldn't give it. And I put a hint in at the last minute, which was basically the answer. It was there. It was just right there. The entire answer, right there on the test. And you know half of them still got it wrong, right? So sometimes you should know this, right? You should know this. Why? Because what are other people thinking? They might be thinking, okay, he's asking me this, but the answer's right up there. So surely that's not the answer, right? So don't do that, right? Sometimes I really am that much of a pushover, all right? So if you think, in fact, if anything, I would go the opposite direction, right? Know that after you see the solution, you will think it's obvious, all right? Know that. So how do you use that fact? If you're thinking the answer is something really weird and complex, you're probably wrong, right? The answer really is going to be bang, 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 right? Each of these little steps here, what I write, will be 2 or 3 sentences, right? Nothing big and scary. Sometimes certainly what I expect from you is 2 or 3 sentences. Sometimes I might write 10 sentences only because I want to flush out the details for those people who really are obsessed with it, right? All right, let's keep going here, right? So now we're doing the loop invariant, right? We're at the top of the loop. We know the exit condition's not true, right? That's useful because, right, we've indexed up to I. We know the loop invariant's not true, so we know there's another guy. So we know that we're not going to bail when we do this, right? Usually, I kind of ignore the not exit condition, but if you're really getting formal, you need to be able to say in this thing, oh, look at the exit condition's not true, and hence it's okay for me to index this array. The world won't blow up on us, right? So anyway, you know the loop invariant's true. You know the exit condition's true. You know we execute this code, and so then when you get back to the top, the loop invariant will be true again, right? And here we're saying, right, m is the maximum of the first number, and then we make m be the maximum of the old m and the second number, and hence m is the maximum of the first 2 numbers, right? Everybody got that, right? And then we do it a second step, right? We show, well, if it's the maximum of the first 2 numbers, and we compare it with the third number, then we got the first 3 numbers. Right? Everybody following this? Now, when we're doing this proving, how many of these steps do you need to do? Why 1? Because he came from Mars. Thank you. Thank you. Right? You go to that Reddit page and you tell them. You tell them that we came from Mars. Right? You hear what I'm saying, guys? Right? We only want to do it once. Right? We don't have enough paper to do it n times. We don't have enough time on the test. We want to do it once. We want to say, we fly from Mars, we have a generic I. We have a generic M. We don't know how many times we've been around. We don't know how we got here.
Almost like a proof by induction.
No. Not almost like a proof by induction. Exactly. Exactly a proof by induction. Right? We're going to do induction in a few slides. This is exactly a proof by induction. All right? Sorry for teasing you, but I got you for a moment. You were like, oh dear. All right, so yeah, see what we're doing here? Right, what we're doing is, well, we have it up until I, we do this, and hence we have this, right? Now, the one thing I don't like about this, everybody get that this is good? All right, the one thing I don't like about it is the loop invariant doesn't talk about I plus 1, right? So we have to juggle going from I to I plus 1 somehow. And so what we're going to emphasize maybe more in other slides is at the top of your proof, I want you to say, well, let mt and I sub t be the values that I currently have at the top of the loop. Right? Or you could make them m prime and I prime be the values at the top of the loop. And then when you come around again, we can talk about mt plus 1 and it plus 1, or m double prime and I double prime. Right? Because this right here, I equals I plus 1, is a fantastic line of code, but as a mathematical statement, it has a sort of a confusing meaning, right? I doesn't equal I plus 1 unless what? That's just not true, right? So what we're going to do is we're going to say at the top, define these things, and then when you say what action does your code take, right? What's not? No. Math isn't about actions. Math is about stating facts, right? You know, if we're in 1090, we're stating a sequence of facts. So this is not about actions. This is about relationships. And so this is an action, right? But this is a relationship, right? I'm telling you the relationship between the old value of I and the new value of I, right? And this is the relationship between the old values. You know, A is kind of fixed, right? So old value of I and the old value of M tells me the new value of M, right? And so what we're writing up here is up at the top we're saying let MT and IT be and T plus 1 be. And then what we're saying is, well, we know the loop invariant is true with respect to these values, right? So you can write down what it means for it to be true with respect to these values. And then here, for the code, you can write down the relationship between the old values and the new values as statements, right? And now we have math statements. And over here, we can prove that the loop invariant is then hence true for the new values, right? And so this is all about mathematical statements, and we've removed action, right? People buying this? You had a question. I know you did, and I ignored you.
It's okay. Just to clarify, so the loop invariant is the one picture that we maintain throughout
Yes.
the code, so that's why we only do it once, right?
Yes.
Okay.
Yes. We're doing it generically, right? I mean, if you wanted to do it every time, you might have to say, well, let's do it not only for every iteration, but for every possible input, right? For every, right? So we don't want to do that either, right? There's your word. What's our last step? Again, we know the loop invariant's true, right? You write it down. What do you know from it? You know the exit condition's true. You write it down. Again, we have some code which tells us some things that are happening, and from that we get the post condition, right? And in our case here, it's pretty straightforward, right? You know this. You do a little figuring out. And again, maybe I should change this to, right, the maximum is returned, because somehow we're going from M a value to the value returned. Right? Everybody good? People following this? And you know this example is too easy, but really you got to get the core steps. Right? Right, so, right, that's just the thing. We said that already. We kind of talked about this already, right? Right, so here, you establish the loop invariant. You maintain the loop invariant. You get the post condition. Everybody's following these? So really, I would say between now and the next class, you really, really need to sit down and, right, memorize these. Right? They're just the core to what we're doing here. And I kept saying last class, steps. Well, these are most of them. It's really not that hard. You can do it. Right? Partial correctness is saying is these three things. Right? Those three things. And usually on a test, these are the three things that I make you do. All right? And what does it give you? It gives you if the program terminates, then you get the right answer, right? So here, I make a chart, right? You got to define the loop invariant in the post condition, but I do that for you, right? You have to tell me what the loop invariant is. You have to tell me that if this is taking a step, you're flying from Mars, the loop invariant's true, right? You don't have to write code for every scenario if you're up in a tree. You know the loop invariant's true. Give me an action. Tell me when you stop. prove to me that if the loop invariant is true, green, by the way, I've generically made to be green go, I'm loop invariant is true, if you haven't figured that out already. Right? Loop invariant is true, you're not exiting, you maintain the loop invariant. Right? This says the little house as I'm going from my house to my school. Right? If my precondition is true, then I can establish the loop invariant. If the loop invariant is true and the exit condition is true, I can get my postcondition. Right? Everybody got my pictures? And so when we go through examples, these little pictures will show up on the screen, and we'll do it. Right? And then you'll know what we're doing is we're getting the postcondition. Right?